Find the derivative of this inverse function. And so let's look at what we have here. Remember, we have a rational function, so we're going to use our quotient rule. So if you remember what our quotient rule is, we need to find the function. We look at the top, find the derivative of it, and then find the derivative of the bottom. Okay? So let's find the derivative of this top function. X and square root, and actually I want to rewrite that. I'm going to rewrite it as an exponential or a rational exponent. My exponent becomes, this radical becomes a rational exponent, minus 1. And then I'm just going to call that other one my h of x function, which would be 1/2 minus 3. And the derivative of each one, g prime of x equals, remember we pull this down, the power rule, and then we subtract 1. Well, subtracting 1 from 1/2 would actually be, think of this as 2 over 2, get a common denominator. So we're looking at negative 1/2. And of course, the derivative of a constant is 0. Same thing over here. We bring our 1/2 down, x, subtract 1, use it according to our power rule, and that half, and again, that. We have everything we need for the quotient to use the quotient rule. And remember what the quotient rule is. We have a function, derivative now, and so it's going to be f prime of g minus g prime all over g squared. So this is what we're going to use, except I'm going to do g and h because I labeled the g function and this is my h function. First derivative for the numerator is going to be ½ power times the second function, which is and that's all divided by, well, let's just run that out there. Let me go ahead and finish this one up. Minus, again, first function, or what's on top, which I labeled as my g function. So that's going to be x to the 1/2. It's supposed to be a parenthesis. X to the 1/2 minus 1 times the derivative, which is 1/2 x to the negative 1 power. And then the whole bottom is the denominator squared, square root of x. We need to simplify. We've actually done the derivative part. We've done the calculus part. So now we just need to all right, so here's our function, our derivative, which is a function. And I know this, I can pull this down to the denominator. So 1/2 2's here. Let me fix that too. Of x, sorry about that, times square root of x minus 3 minus square root of x minus 1. And this again is 1 over 2 square root of x. And all of this is over this square root of x minus 3. And we can do a little more to make it look a little better. Actually factor out (1/2) square root of x. See, that helps us out any here. X equals 1 square root of x. And then that's going to leave us with all this inside here, this square root of x, minus 3 minus square root of x plus 1. I just did that negative. And what's nice, as you can see, these actually cancel out. Left with negative 3 plus 1. So see what happens there. Let's not forget about our denominator. Square root of x minus 3. Now all of this, mind you, is just algebra that we're doing. We've done the calculus part. Okay. So, looks like I have 1 square root of x going to be times, well, negative 3 plus 1 is negative 2. And all of that is over this square root of x minus 3 squared. Well, it looks like we have a little more cancellations here. These 2's will cancel out, excuse me. All right, so we're almost there actually. Equals, so those cancel, so I'll have a negative 1. This we can drop down to the denominator. So we really would have square root of x times square root of x minus 3 all squared and a negative 1. We could multiply this out. I don't need to. We're good right here. And it actually might take our first answer. It depends on how picky the program is wanting to be. It might actually take that one. But this is a little better, simplifying